doing good day in pre-algebra. We are going to be going over the first half of PO15, talking about some tidbits and tricks to help you. Then the second part of it will be homework for tomorrow. So this first page here, we kind of started with what's called combining like terms. We filled a whole bunch of definitions with terms and coefficients and constants and like terms and things like that. And your job, you needed to circle the coefficients, box the constants, underline like terms, and ultimately simplify the expression. So that coefficient, I mean, we did the first three together, right? Is that all we did? I think the first three. The coefficient, its role is it tells you how many of the variable you have. So it's the number that comes before the variable. So in this one here, it's 14, positive 8, remember that sign belongs to it, and positive 3. And the reason why that's important is because when we go to combine like terms, that's how we know what to combine and how many n's we have. We start with 14, we add 8 more, we add 3 more. If you have 14 of something, get 8 more and 3 more, total you have 25 of that something. We don't know, right? We don't know what n equals, but whatever it is, we have 25 of them. Okay, 18 or 14 plus 8 plus 3. The next one, we've got 20 n's. We've got negative 2 n's here. And I'm going to circle this coefficient in a different color. Why would I circle that negative 3 in a different color than what I circled the 20 and the negative 2? Jacob?
Variable?
The variable is different. So it is a coefficient, but I'm not going to be able to combine it with the 20 and the negative 2 because that's talking how many n's I have versus the negative 3, which is how many x's I have. So it's still a coefficient, but it's not going to be able to be combined. And then box the constants. So we have positive 13 and negative 5, both without a variable. They are constants. My like terms, I've got 20 n's and negative 2 n's there. Total, that gives me 18 n's. I've got 20 of them. I subtract 2. Then I've got my negative 3x, which I can't combine with that because it's not the same variable. No like term to combine with that. And then my constants, positive 13 and negative 5. 13 minus 5 is a positive 8. Okay. Sometimes folks, how do I know if I'm adding or subtracting? Well, remember that addition or subtraction sign, it belongs to the number, right? We're adding 8 because it's positive 8. So when you take 13 minus 5, positive 8, you write that as plus 8. Okay. The order of this, it could be different. Maybe you have your negative 3x first, then your plus 18n, then your plus 8. It doesn't really matter. Okay. Typically, though, you'll see variables written in alphabetical order and then constants last. So I kind of have the habit of doing that. But questions on that one? Okay. All right. Next one. We've got negative 4 as a coefficient, positive 8 as a coefficient. They are like terms. We'll be able to combine them. And then our constants, positive 5 and negative 10. Who would like to share the simplified expression they got for this one? I think you're all already bored of me. So anyone else like to share the simplified expression that they got after combining like terms? Yeah. 5 times negative 5? Where do you get... 5x. So these x terms here, negative 4 plus 8. Negative 4 plus 8 is a positive 4. Okay? So it's actually going to be 4x, not 5x. Negative 4 plus 8, positive 4. And then we're not going to be multiplying our constants. They're going to come after it as either addition or subtraction. Okay? What's 5 minus 10? Positive 5 and a negative 10. 5 minus 10. Yvonne? Negative 5. So we would just write that as negative 5. 4x, negative 5. Remember, this x now, you're so used to x meaning that you're multiplying something. And so maybe you would read this as 4 times negative 5, but that's not what that x represents. in pre-algebra and algebra going forward, x is going to be used more as a variable, okay, an unknown number. We are multiplying 4 and x together because there's no operation written between the coefficient and the variable. It's understood that we're multiplying, but it's not going to be 4 times -5. Okay? For multiplication, we use the dot, we use parentheses, things such as that. But 4x minus 5 for that one. Questions? Okay. Third row, first one. Let's get to circling here. Our coefficients, we've got +8. I'm going to circle my -6 and my -2 in that same color. I do have another coefficient, that +4, but I'm going to circle it in red because I'm not going to be able to combine that with my x's. It's got a y, not an x. They're not like terms. Then my constants, only one of them, +11. There it is there. What are my x's combined to be? I've got 8 of them. I subtract 6 and I subtract 2. What do I have left? 8 minus 6 minus 2. You're all in 7th grade, right? 8 minus 6 minus 2. You find 0. Okay? Everything cancels out, right? You have no x's left. So if you want to write that as 0x, then you can. But 0 times whatever x is going to be 0 anyway. So you can either write 0x or just remove the x's completely because they all cancel out. 8x, -6x, -2x, they all cancel out, right? So really, we're left with our y term, which we can't combine with anything, and our constant, which we can't combine with anything. So 4y plus 11 would be our simplified expression. Get rid of all those x's there, okay? Next one, -12n plus 3n minus 7 minus 2n. Looking at our coefficients, -12, +3, -2. We have our constant, which is -7. Okay. All those variable terms, like terms, can be combined. -12 plus 3 minus 2. Anyone want to share what they came up with here? -12, add 3 to that, then subtract 2. What's -12 plus 3? Oh, yeah, go ahead. -11, the price is right. Okay. -12 plus 3 is -9. -9 minus 2 gives us -11n. And then our constants, -7, no other constants to combine that with. And so it's left as -7. And the last one on this first page, again, our coefficients. We have a 4, a +2, a -3. This time I get to circle a different coefficient twice. I got some y there also. And then our constant, which looks like it's the only one, -9. How many x's do we have total here? +4x, +2x, -3x. What does that work out to be? Aiden? 3 of them. So we're going to put 3x. How many y's? -7 plus 13. Aiden again. Not 2. -7 plus 13. 6y. And then our constant, which can't combine with anything, is just going to drop down as -9. Okay, that sign follows it. That's important. That's why I want to make sure that we're boxing that sign, circling that sign with it. It belongs to it. So 3x plus 6y minus 9. Okay. Yes, Aiden?
I thought you were asking me how many y's there were.
Oh, how many y terms? I gotcha. Yeah. Sorry. Overall, when we simplify it, there are 6 y's that remain, but there are 2 terms that contain the variable y. Good clarification. Anything else? Ooh, jeez. Okay. On the second page, here's where we were introduced to the distributive property. And basically, what the distributive property does is it allows us to get rid of parentheses in an expression, which is going to be important once we start to solve equations with parentheses in them. We're going to have to get rid of them. And this is one method to do so. So what we talked about was you're multiplying everything inside of the parentheses by the coefficient on the outside. Right? 8 times n plus 7 is the same as 8 times n plus 8 times 7, which of course we would then write as 8n plus 56. And that would be your final answer. You wouldn't combine that to get 64n, right? Because the 8 has an n, 56 doesn't. We got to keep them separate. They're not like terms. So this one, 10 times n plus 5, the same as 10 times n plus 10 times 5. And we get 10n plus 50. That's as far as we can go. Okay. Negative signs matter here. When we distribute in this 6, it's going to be 6 times 2n minus 6 times 4. Okay. Or another way to think about that is plus 6 times negative 4. Either way, you've got to make sure that you're subtracting 24 from your 12n. 6 times negative 4 gives us that negative 24, and we write it as 12n minus 24. Fourth one here, negative 5 times 3n is a negative 15n. Negative 5 times negative 11 is a positive 55. Check your sign on that. Right? You've got a negative coefficient, a negative constant in your parentheses. A negative times a negative will be a positive. It is so important to remember that that sign belongs to it. Okay? The details matter here. Next one. Who'd like to share what they got for that one? Negative 9 times negative 4n plus 9. Anyone bold, brave, willing? Go ahead. 30. Oh, I can write that 3 better. 36n minus 81. The price is right. Okay. Negative 9 times negative 4, positive 36. Negative 9 times 9, negative 81. Perfect. Next one. 2 times 3n minus 10. Who wants to get in on the action? Aiden.
6n minus 20.
6n minus 20. 2 times 3n. 2 times negative 10. 2 times 3n is 6n. 2 times negative 10 is negative 20. Now, some of you worked ahead, and this was the end of your homework here, right? Some of you worked ahead to these other two, which is bold and brave of you, but I kept these off for a reason, because they look a little bit different than the other 6 you had here, right? What's being distributed in parentheses in this first one here? What are we going to be distributing into the parentheses? Aiden?
2n plus 8.
Well, we can't combine 2n plus 8, right? Like we can't write 10n because they're not like terms, okay? And also, notice the addition here. The addition is separate from our parentheses. It's separate from the multiplying, okay? If we follow the order of operations, we've got to do this part first, right? Because that multiplication comes before the addition. That 2n is not part of that parentheses. So actually, Gigi, what were you going to say? Right. So actually, what gets distributed in the parentheses is only the 8. Only the positive 8. This 2n just kind of drops down, and we'll deal with it later. Right? It's kind of like those other order of operations things you did back in CO11, where you do part of it, and just everything else just kind of comes down to the next step. That's what's happening here. That 8 gets multiplied by negative 2n. Positive 8 times negative 2 is a negative 16. Check that sign. And then positive 8 times a negative 7 is a negative 56. Okay? And now that we've distributed and gotten rid of those parentheses, what can we do with that 2n? How does that come into play here now? Aiden.
Minus it from 16.
Yes. 2n and a negative 16n, or 2n minus 16n, is what? 2 minus 16. Coming back to PO3 where we're adding and subtracting negative numbers. Go ahead. Okay, Ifan? Negative 14. That negative 56 doesn't change because there are no other constants here that we can combine that with. But our final answer is a negative 14n minus 56. All right. The next one is really set up for a trap because it's so tempting to subtract that 6 minus 3 out in front, right? But can we? Mathematically legal to subtract 6 and 3 first? No, because we have to take care of our multiplication. And what we're just distributing into parentheses is that negative 3. It's like a double trap, right? You can't combine 6 and 3, even though you might want to because of order of operations. And then that negative sign belongs to the 3. It gets distributed in with it. So negative 3 times 4n is a negative 12n. And a negative 3 times a negative 5 is a positive 15. Check your signs. Negative 12n and a positive 15. Now we can use that 6. How does it come into play? 6 minus 12n plus 15. Let's get someone we haven't heard from yet today, perhaps. A new voice. Heard from you. We've heard from you. Heard from you. Six is a constant. So is that positive 15. Therefore, they can be combined. Okay? That negative 12n doesn't have any other n's to combine with, so that just remains negative 12n. But 6 plus 15 gives us positive 21. So our final answer is negative 12n plus 21. So especially if you worked ahead here and did these two as part of your homework, make sure that you've got the correct answer because you're probably going to want to look back to them as you get down to some of these in the second section. Okay? Questions on those 8s? All right. So your homework then for tomorrow, and we can jump right in and do some of these together, but this second section, okay, it says choose a value for the variable and check to see that the original expression and your answer or your simplified expression have the same value. So it's the same stuff you've been doing as far as combining like terms, distributing, but now I want you to take the time to check the answer. And I'll show you exactly what I mean by that when we do one together. So one from the first row that you'd like to do. One from the first row, yeah. The fourth one, negative 6 minus 3n minus 7 plus n. Okay, what are like terms that we can combine here? Let's underline those like terms. Connor? Negative 3n and n. And sometimes this can be a little bit tricky because how many n's do we have there? What's the coefficient to a variable when it's by itself like that? It is 1. It's not written. It's just kind of understood. Then when there's just a variable by itself like this, it's saying that we've got one of them. So we've got negative 3n's plus 1. What will the coefficient, the n term, be in our simplified expression? Negative 3 plus 1. Maggie? Negative 2. Good. Okay. And then we've got some constants here also, right? This negative 6 and negative 7. What do negative 6 and negative 7 combine to be? Negative 6 and negative 7. We take it just as it's written here. Negative 6 minus 7. Connor? You found your hand up? Negative 13. So negative 2n minus 13 would be our simplified expression here. Negative 2n minus 13. Now for the checking. Okay, what we need to do here, and you do need to show this, that's why I gave you so much space here to show this checking part. You don't want to pick a number like 5 billion. You want to make it manageable, something simple to work with here. So give me a number between 1 and 10 that you want to plug in just to verify that this all works. 6. All right. So if we plug in 6 to the original expression, we've got negative 6 minus 3 times 6 minus 7 plus 6. Okay, I just replaced the n variable with 6 because that's what we just picked. There's no rhyme or reason to choosing 6. There's not some, if you're wondering, how do you get the 6? We just picked it. Favorite number between 1 and 10. Okay, so if we solve this now, I'm going to actually be working upwards here, so just follow it. But we've got negative 6. Negative 3 times 6 is a negative 18. And then minus 7 plus 6. Okay? And you can use your calculator for this to check too. I know our strength in addition and subtraction, particularly with negative numbers, kind of varies from person to person. Something like this, we got several of them here, and you're just checking it. A calculator is a terrific tool. Negative 6 minus 18 minus 7 plus 6 is what? Who's got that? Negative 6 minus 18 minus 7 plus 6. Anybody? Yeah. Well, it's right there. Negative 6 minus 18 minus 7 plus 6. Yes, please. It's negative 6 minus 18 minus 7 plus 6. Negative 25, people. Negative 25. Okay, that's what we get from the original expression when we plug 6 into it. And if you're thinking, well, I didn't know how to. That was a lot of thinking. That's why we simplify, right? Because our simplified expression, negative 2n minus 13, if we plug in 6 for n in this expression, it's just negative 2 times 6 minus 13, or negative 12 minus 13. That's also negative 25, is it? Right? Yeah? Yep. Yep. So, nod your heads yes, please. Okay? And the fact that these two things are the same tells you that you've done it correctly. Okay? If you get a different answer for plugging in a value into the original expression and your solution, then something went wrong. Okay? You did not simplify correctly. Simplified expressions have the same value when you plug that variable in. All right? Give me one from the second row that you'd like to do together. Aiden.
Negative 4 and then parentheses.
The last one?
Yeah.
Okay. So this one, similar to the one above it there, we had that I almost said imaginary. It's not imaginary, but we had the unwritten 1 in front of that n. In this case, what are we going to be distributing into the parentheses? It's the negative sign, but that negative sign is not really a number. What are we distributing into the parentheses? Pierce. Oh, there's no n in front of those parentheses there. It's that unwritten 1 again. Maggie, what are you going to say? Yeah, but it's going to be a negative 1, right? This is the same thing as negative 1 times 4n minus 12. Sneaky. Okay? We don't write it. It's understood that coefficient is going to be a negative 1. So when we distribute, since we're multiplying by negative 1, we understand our rules of multiplying by 1 negative signs, all that really happens is that what's inside the parentheses, the sign changes, right? Negative 1 times 4n is a negative 4n. Negative 1 times a negative 12 is a positive 12. Okay? And that's our simplified expression. No like terms to combine. Okay? We've distributed, got rid of the parentheses, and there we have it. Give me your favorite number between 1 and 10. 1 and 10. Anna? 7. So if we plug in 7 into the original expression, whoops, there we go, we get negative, and then in our parentheses, 4 times 7 minus 12. Okay? Or, doing our parentheses here, negative 28 minus 12. 28 minus 12, 16. We make that negative because that sign out in front, and so we get a negative 16 as an answer here. If we've done this correctly, what should negative 4n plus 12 equal? If we've simplified it correctly, what should negative 4n plus 12 equal? Aiden.
8.
No. If we've done this correctly, our simplified expression should equal our original expression when we plug in the same number. Because equivalent expressions, simplified expressions, will have the same value. So we plug in 7 for n down here. Oh, now my board decided to reboot. Of course. Negative 4 times 7 plus 12. Or negative 28 plus 12 is what? Negative 16. We know we've done it correctly because we've plugged in the numbers and we've checked. Okay? Checking is going to be part of your homework. I need to see that you are checking this. It's going to help your understanding. Okay? It's going to give you a tool to use on a test. Make sure if you've done it correctly, right? This is one of those ways that you can cheat in math, and I encourage it. Check your answer. You know, you can't look up a date in a history book on a history test, but you can look up, so to speak, whether you have your expression correctly doing this. So I need to see it as part of your homework. These 12 expressions, the 10 that remain, will be homework for tomorrow, and that's all you have. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? All right, that's how you math.